Now the question is, why do objects get charged at all? What is the reason for objects getting charged? We remember what we have shown here is why electron got negative charge. Now the question is, why do bodies get charged? Because right now around you see neutral bodies. You don't see any charged bodies. You don't see anything attracting anything. So the question is, why do bodies get charged? So let's try to answer this question. So for this question we have to go inside atom. So why atom, you may ask? So the answer for that is because everything around us, it's made of either atoms or molecules. So that's why we need to understand that thing. So what happens that the body gets charged? So as we know, everything is made up of atoms or molecules. So let us draw a structure of atom. So how does atom looks like? So now electrons, this is nucleus, and within that we have protons. Remember this is a simplified form. This is not how atom actually looks like. So we'll study about it when we study chemistry, about the atom structure and all that. So right now just remember, this is not how atom looks like. So this is the most simplified version in order for many other things to be simpler. So that's how we define it. So what happens is, so right now you see objects around you, all of them are neutral. Why they are neutral? Because they have equal electrons and equal protons. So that's why everything around you seems to be neutral. Now what happens is, there are many processes. We'll study about the different techniques. So due to these different processes, what happens is, the electron, because they are loosely bound, so the outermost electron, the valence shell electron, they can be easily removed from the atom. So what this does is, if let's say for example, if I have 3 protons and 3 electrons, so if I somehow remove 1 electron, so we have just 2 electrons. So initially we have plus 3. Now what we have minus 2 here. So initially we had minus 3 as well. Now when I remove 1 electron, this causes imbalance. Now what we have is extra protons and less number of electrons. So this gives it a charge. Or what might happen is, somehow this atom might get an extra electron. Maybe due to rubbing or due to touching, conduction. So these processes, this atom might get an extra electron. So this also, what this does is it charges this atom. So in the same way, if I have an object, so each atom gets charged. So that's why the body as a whole, it gains electron. So the atoms that are in contact, so they gain electron or either lose electron. That's why the body gets charged. That's the simple reason why a body gets charged. Now the question is, why? What are the processes? How does it charge? So we answered why does a body get charged. Now let's answer, how does a body get charged? How does it get charged? So now the processes that we have for charging, the first one that we have is friction. So that's the most famous one. So what happens in friction? So the same way what happens in friction is, when you rub an object with the other object, let's say if I have a silk cloth here and if I have a glass rod here, if I rub the glass rod with silk cloth, the glass rod becomes positively charged. Why does it become positively charged? It loses electrons and it gives it to the silk cloth. So that's what happens. So this is one of the effects due to by which a body becomes charged. So this is also triboelectric effect. Triboelectric effect. So what is triboelectric effect? So triboelectric, when you rub objects, they become charged. That is what is known as triboelectric effect. So tribo is a Greek word which means rub. So Greek for rub is tribo. So that's why triboelectric. Rubbing, it gives it electric effect. And just go online and search for triboelectric series. triboelectric series. So what is triboelectric series? Triboelectric series, it will give you a list. So it arranges different objects based on their capability of losing electron or gaining electron. So that's how it is. So above you will find positive, and if you go down below you'll find negative. So what is positive? So these objects, they can easily lose electron on rubbing, and what are negative? They can easily gain electron when rubbed. So before downwards, what we'll have is, we'll have silk as an example. All right, then we will have what do we have here? So we have PVC, all right, polythene. So these are the examples that we have here. And above, what we'll have is glass rod, then we'll have wood. So these are the examples that we'll have above, positive ones. So these things, they can easily lose electron, and these things, they can easily gain electron. So this is what is known as triboelectric series. Remember triboelectric effect and triboelectric series. And just one more thing I want to, just for your information, just remember this term. This is known as electrostatic cling. So what is an electrostatic cling? So when you rub your scale or glass rod, and then you try to attract objects like paper bits, so the paper that sticks on scale, so that phenomena is known as electrostatic cling. Remember this. Alright, now let's move on to the other technique that we have for charging object. So before that, let me show what the scale one. All right, let me show how you can attract, how does the friction thing works, like when I rub scale and I can attract. So you might have seen before as well, so just see it with a different vision, see it with a different idea altogether. All right, let's see that. Okay, now let's discuss friction by charging, the method how we charge by friction. So I have here small cut out paper bits, pieces of paper finely cut, and here I have plastic scale. What I'll do is I'll charge it by friction, the scale by friction. How do I do that? I'm rubbing it on my head. So while rubbing, the scale is gaining electron and my hair are losing electron. Now this has become charged. How do I know the scale is charged right now? Okay, I'm putting it over the paper bits. You see, the paper bits are being attracted by the scale without even touching. See that? So this is charging by friction. The method by which the scale is attracting the paper bits is charging by induction, but the method by which I have charged the scale with my hair is charging by friction. And what is happening? The scale is gaining electron and my hair is positively charged because they are losing electron. And the plastic scale, it has gained electrons from my hair, so it becomes negatively charged. Okay. So what we saw was the scale was attracting the paper bits. Why was it attracting? Remember, this scale is plastic. Alright, so scale is plastic. So when this plastic, when I rub it on my hair becomes positive charged, and plastic, it becomes negatively charged. So that's why plastic becomes charged. So that's why it gains the capability to attract objects. Now let's move on to the other technique that we have. So the second technique that we have for charging is what we call conduction. Conduction, or this is also known as contact charging. So charging by contact. So what happens in contact charging or conduction charging? So if there is an object, we just touch it. I have a charged object in my hand and I touch it to a neutral object and I charge this object. The neutral object, it becomes charged just by touching. Remember, in friction we are rubbing in this, just by touching the other object it becomes charged. So what are the examples for this? Let's say if I have a glass rod, so this is glass rod. So glass rod, what I have is, remember when rubbed with silk it becomes positively charged. So if I have a pith ball, what is pith ball? The same thing. Pith ball are similar to polystyrene balls, just those small styrofoam balls. Just check for styrofoam balls. You might have seen these small balls, but just go online and search for styrofoam balls. So this is one, or similar to thermocol balls. Alright, so when you touch it with, these become easily charged. So when you touch it with glass rod, it becomes positively charged. Now what happens, remember what happens in conduction is, now this glass rod is touching this neutral, firstly it was neutral, alright, neutral pith ball. Now upon touching, few of the electrons of this pith ball, they come to this glass rod. So that is what is happening, alright, because the electrons are the free ones that can move. So that is what is happening. Now let's say initially it had +5 charge. Let's say as an example, let's say if this glass rod had +5 as the charge, and this was neutral, alright, initially. This is initial case. Now what happens on touching is, this loses electron. When this will lose electron, this will become positively charged. When this loses electrons, let's say if it loses 2 electrons, this will become lesser positive charge. This becomes, so -2 +5, -2 is the charge on electron, +5 +3. Alright, so this is what happens in conduction. The object that has the charge initially, its charge becomes lesser in value. So initially it was +5, then it becomes lesser in value, it becomes +3. Alright, so this is what conduction is. Now let's study the third type that we have, which is known as induction. Remember, friction, then we have conduction, and the last one is induction. Induction is the most famous one. Induction, there are many phenomena associated with this induction. So what is induction? Alright, so induction is inducing charges. Inducing means producing charges. When the charges are not there, so when we take an object closer to an object, we are not touching it, remember, there is no touching going on. So let's say if I have a glass rod and if I take it near a metal ball, so this metal ball, the charges are induced in this metal ball. There were no charges before, it induces charges, it produces charges. Alright, so that is how the induction works. So it is also known as no touching or charging at a distance or action at a distance. So this is the magical phenomena, the ones that magicians were doing in Queen Elizabeth's court. So this was something they were doing. So they were inducing charges without touching, no contact is there, action at a distance. So the paper bits that were there, so they were being attracted to the glass rod because the charges were being induced on the paper. Alright, so that's how the induction was working. So let me show you a few things, phenomena related to that. So this same, I'll show you the one that we saw, the before one, and just remember what is happening. Alright, so I want to show you the PVC and the aluminum foil once again, and just see through different vision and through different viewpoint what is happening. Alright, let's see it again. So now, since we have learned about induction a bit, so let me explain how induction actually works. So the magic trick that we saw before, that was done in Queen Elizabeth's court. So at that time it was sheer magic, but for us, we know now how did the magic happen. So science has revealed the secret for us. So let's see how it happened. So firstly, so these are the aluminum foils that I have. So now, so the rod is being charged, the PVC rod is being charged. Now, when PVC rod is being charged, you see, so this is being charged negatively. So it's negatively charged. Now, this is attracting aluminium foil. So how is this happening? So this negative charge is polarizing the aluminium foil. So that is how it is happening. So this polarization, so negative charges, so the electrons in the foil, they are repelled, and the positive charges, they are attracted, leaving the positive charges in aluminium, and they are attracted to the PVC pipe. So this is magic revealed finally. Okay then. Alright, so now what we saw was, let's see figuratively what we saw actually here. Alright, so what we saw was, we had a PVC, alright, and then we had aluminium foils, aluminium foil, alright. That was the, now the PVC, as we know, PVC is negatively charged. This is what is happening. PVC is negatively charged. So it's negatively charged. Now when I bring the PVC near aluminium foils, so initially the aluminium foil, let me draw a bigger structure of aluminium foil. So let's say, for example, this is the enlarged version of the aluminium foil. Now the aluminium foil, initially it's neutral. There are no charges. What happens is, when I bring PVC near it, because the PVC is negatively charged, the negative charges that are there on this, the free electrons. So aluminium has free electrons, it is metal. So the negative charges that are there, so they move to this side, opposite side. Why? Because like charges, they repel, so negative, and the electrons move on the farther side of the foil. The positive charges are still there. Why are they there? Because we know atoms are neutral, alright. So the atoms that are on this side, so they had initially electrons, so before it was neutral. Now what happens is, due to this negative charge, the electrons that were there, they move farther, they move to this end, leaving the positive charge. Remember, the positive charges are generated because there is lack of electron. Alright, there is no positive charge that is coming. Positive charges are just lack of electron. So positive charge, initially this atom was neutral. Now the electrons, they move to the farther end. Now this is why there is attraction that is going on. So this is what is known as the action at a distance phenomena, or the induction phenomena. Now I want to explain you two major things. So this is how induction of charge, action at a distance, or induction, charging by induction is helpful. So first one is charging a metal ball positive without touching. Alright. Now how do we do that? How do I have, let's say I have a metal ball here. It is mounted on an insulator. So this is an insulator, alright, the below one. This is a metal ball. So this is an insulator. So how do I charge this ball positive without even touching? How do I do that? That's the question that we are asking. How do I do that? So what I do that for this thing is, what I'll do is, I'll take a plastic rod. So remember, plastic rod, when rubbed with cat's fur, it becomes negatively charged. Alright, so now what I'll do is, so plastic rod is negatively charged. Now when I bring this plastic rod near this metal ball, what happens, remember, the negative charges, negative electrons will go to the farther end, because same charges they repel, so the negative charges will move to the farther end and the positive charges, they'll remain here, the positive ones that are there. Now what I'll do is, I'll keep this state, keep this closer to this, the plastic rod, I'll keep it closer to the metal ball. Now what I'll do is, in the next step, so this is first step, I'll mark it as A. Now in the B step, what I'll do is, I'll ground, so this is negative plastic rod still there, and this is what, these are negative charges at the farther end and positive at this end. So now I'll ground this metal ball. What is grounding again? Grounding is leaking the charges to the ground. That's what grounding is. So the excess charges that are there, we send it to ground. So ground is basically earth. So earth is very big, very huge, 6400 kilometer, that's the radius, alright, of earth. So it can take any amount of charges. So when a body has an excess charge, and if you ground it, because earth itself has metal ore and metals in its core, in its center, so that's what happens. So when you so earth is basically a conductor of electricity. So when you attach excess electrons to the ground, so they move to the ground, because that is where earth is the conductor. So excess charge moves to the ground. So that's why grounding is done in your homes as well. So let's say if any wires or if any appliance, it gets excess charge, so it will move down to the earth. So that's what grounding is. So that's what, so grounding is represented by this sign. So this is the sign of grounding, dash dash dash. So that's what ground is. So now the excess charge, this negative electrons, because the electrons can flow, they'll flow down to the earth's surface. So now we'll get the final result. Now what we'll do is, so the excess electrons will flow, and now we'll remove this negative charge. So we'll do it in two steps. So firstly, we have negative plastic rod here, then we have metal ball, then we have insulator. Then what will, it's same, alright. So the electrons, they flow down. Now still we have the positive charges attracted to the negative the plastic rod. Now in the last step, what we'll do is, we'll remove this plastic rod that is there, and hence we'll get this thing, positive charges all, because there is nothing to attract this, alright. So we will have positive charges everywhere. Why? Because this will redistribute itself, the positive charges, because there is nothing to attract this, so the positive charges will be everywhere. So why? Because the electrons that are there here, the electrons will come here, and few electrons, so thus creating a positive charge all over the surface. Alright, so that's how I can charge the metal ball positive. Alright, so now let's do the second phenomena, that is charging the metal balls positive and negative. Alright, so we have, let's say, two metal balls, and what we'll do is, we'll same on insulators, and what we'll do is, we'll charge both of these metal balls opposite charges, both positive and negative charges, without touching these balls. That's the magic of induction. We will charge it at a distance, that's why it is known as charging at action at a distance. So what we'll do is, we'll bring a glass rod. So what is a glass rod? Glass rod is positively charged. So glass rod is positively charged. When we bring this glass rod in front of these, so what we'll do in the first step, we'll touch these spheres together. This is what we'll do. So when we touch these spheres together, this is glass rod. So what happens is, because this is positively charged, so all the negative charges, they'll come here, just leaving positive charges here. at the other end. Now what we do in second step is we keep this glass rod at its position, so the glass rod is positively charged. Then we separate these metal spheres a bit. Right, so this we are separating the metal spheres a bit. Now the negative charge which is there, it will be there, negative charge, because it is attracted to the positive charge here, and the positive charge will be there on this sphere. Now what we'll do is we'll remove this positive metal rod, we'll remove this positive glass rod. So when we remove this positive glass rod, what happens is, so because these two are oppositely charged, negative metal ball and positive metal ball, so they will attract each other because they are oppositely charged. So now the charge will come to this area. Alright, so let me make that. So this is the metal ball that I have with me. So this will be negative charge and this will be the positive charge. So positive charge would be here. Alright. Now what we'll do is we'll separate these metal balls. The distance would be large compared to this now. So now finally what we get is, fourth step I'm writing here. Finally what we get is, so two different metal spheres separated by a distance, and this negative charge will distribute itself over the whole sphere. So negative charge would be here over the whole sphere, and this positive charge would be here over the whole sphere. Remember, in metals we don't have positive charges moving. We do have positive charges moving in case of ions like NaCl. So whenever NaCl is in molten state, Na plus sodium ions, they move. But in case of metals we have only electrons moving. So what happens is, so this positive charge will redistribute because the negative charges from other negative electrons from other sides will come to this area. So leaving positive charges over the other places in the whole metal ball. So now what we get, the result would be two metal balls. One would be negative and other would be positive. So what we have done here, so without even touching the metal balls, we have induced charges, both oppositely charges, negative and positive charge. That is what we have done. Now let's discuss an instrument that we use heavily for knowing whether a body is charged or not. Alright. So now the question is, so when I'm rubbing a glass rod with silk, so I know that rod is charged. The reason being, when I'm putting that glass rod over light objects like paper bits, so it is attracting that small paper bits. But the question is, how do I know, if I don't have paper bits, how do I know that the glass rod has a charge? Or how do I know for that fact that anybody that I see in my vicinity has charge? So for that we have an instrument which is known as electroscope. So that's the instrument which we use for knowing whether a body is charged or not. So this is the instrument that we use. So let me show you how electroscope works. Then we will look into the explanation, the working of electroscope. We'll look into the reasoning behind how electroscope works and why does it work that way. Okay, let me show you electroscope first. So now here we have electroscope with us. What I have here is a cotton cloth, then we have a PVC pipe, and the last one that we have is a plastic scale. So what electroscope does, as we already explained, electroscope gives the indication of charge on a body. So if I want to know whether there is presence of charge on a body or not, I'll use an instrument which is known as electroscope. Okay, so let me explain the structure of electroscope, then afterwards we'll discuss the theory about it. So on the top, what I have here is a copper wire. So this copper wire, this is insulated by the plastic straw and going down. So this copper wire goes down, and with the copper wire what I have is two attached leaves, aluminium foil leaves. So these are just leaves, they are loosely bound. Alright, so once I give them charge, they'll repel. The repelling gives me the indication that there is presence of charge. Okay, so let me show you how it works. So firstly, what I'll do is we'll charge this scale. So this is a plastic scale. Let's charge this. How do we charge it? The same old method, by rubbing it with here. So I'm currently rubbing it with on my head. I'm rubbing the scale, and afterwards let's see what effect does it have on the aluminium leaves. So right now they are at the stable position. So when I bring the scale near the copper wire, you see magic happening here. You see this? I'm not touching the copper wire yet. So you'll see the scale producing deflection. I'll charge it more. Let's see how much deflection can we produce. Okay. So now we see deflection again. Okay, so it's good enough deflection. Alright, so now let's try with PVC pipe. So how do we charge PVC pipe? So rubbing it with cotton cloth. So the deflection is lesser as compared to the scale, plastic scale, but still we'll give it a go. Okay, so I'm charging it. Okay, now let's see. Alright, so the deflection is not as much profound as we had in the plastic scale, but it still gives a deflection. Why is the deflection there? The plates, the aluminum foil plates, they are being oppositely charged. So they are being same charge. So when the same charge occurs, so the plates repel each other. So I'll explain more about after this experiment regarding theory. So just look. So just let's give the scale one more go. Let's see if we can have more of the charges. Oh yes, we are having slight deflection. Alright, so this deflection gives the indication how much charge is there on either the scale or the PVC pipe. Alright then. Okay, so now we saw how electroscope works in terms of the experiment. Now let's see what actually makes electroscope work. Let's look inside electroscope. So what is the structure of electroscope? So here there is a metal ball, so in my case I had a metal wire on the top, then there is a glass jar, then this metal rod. Alright, so it has at its end foils. So we can have these foils can be either aluminium foils, golden foils, we can have any foils. So the only thing is these have to be metal. I'll explain you why. So this is the basic structure of electroscope. Now how does an electroscope work? So there are two methods. So one is by conduction or contact, and the second one is by induction. So we'll discuss each process, how it works. So before that, electroscope was invented by William Gilbert, the same person who was responsible for explaining Earth's magnetism. Alright. So now what happens is, so firstly we'll discuss conduction. What happens in conduction? So for example, in my case I had a PVC pipe. So PVC pipe is negatively charged. As we already know, so when PVC is rubbed with cotton, what we get is a negative charge. So this is based on triboelectric series. I told you before. So this negative charge, so when I touch with this metal plate above this metal plate, so what happens is, so this negative charge will be transferred to this metal plate. Alright, so this negative charge will be transferred to this metal plate. What happens is, so this is the negative charge that I brought near that. So this negative charge will be transferred to the whole metal plate. Alright, so now when this additional electrons, when they go to these aluminium plates, so these aluminium plates, they repel. The aluminium foils that are there, they repel. The reason being, the negative charge repels, like charges repels. So that's how I know that this body is charged, because the electrons that are there, the negative charges, what are negative charges? Electrons. So electrons will move on to this. So when they move on to this, they get transferred down below to these aluminium foils, and these aluminium foils, they repel each other. Now the other method that we have is by induction. So what happens in induction, as you already know, it's action at a distance. So these, so they don't touch with each other. There's action at a distance. So what happens here is, so now let me explain that. So now there is no touching involved. All right. So when there is no touching, so when I have negative charge in front of me, so this negative charge, when I bring it near this metal plate, because metal has negative electrons, we know that metals have free electrons which can move. So when this is brought near to this metal plate, so this becomes positively charged. This area, the metal plate, it becomes positively charged. Why does it become positively charged? Because the electrons that are there, they get repelled by this. So when they get repelled, so they move down below to these aluminium foil. So when they move down below to the aluminium foil becomes negatively charged. And again, since both plates are negatively charged, they'll repel each other. So that's the working of electroscope. That's how electroscope works. The basic principle is, it is an instrument which is used to check whether a body is charged or not, and how much these leaves repel gives an indication of how much the body is charged. If these leaves repel a bit, then the body is charged in lesser amount, and if they repel and if the deviation of these metal plates is more, so then what it means is we have more amount of charge. So that's how the whole electroscope works. Now what we do is we move on to properties of electric charge. We've already established what is an electric charge and how does body get charged and why does a body get charged. Now let's move on to electric charge. What is an electric charge? The properties of electric charge. All right, let's see that.